In the first video, we ranked the first three arithmetic problems involving fractions from easy, medium to hard. And what came out right in the middle was the division problem. The reason why is because a division of fractions is essentially a multiplication problem in disguise. What makes it medium, though, is that you actually have to turn it into a multiplication problem to get started. And here, let me relate this to a much simpler problem. And it goes like this, dividing by 2. Let's say, for example, you have yourself a calculator. Someone, maybe you have a younger brother or sister, and they started pounding on your calculator and they broke the division key like right off of your calculator, so you cannot divide anymore. So is there a way that you could still divide by 2? Sure you can. You could just turn that into multiplication by multiplying by 1/2. And now I'm going to come back to this 2 over here, and I'm going to write that 2 as 2 over 1. And if you study these two numbers, 2 over 1 and 1 over 2, you can very clearly see that they are reciprocals of each other. Remember, a reciprocal just means you take a fraction and you flip it over. And so that's essentially what we do whenever we are dividing fractions, is that we turn it into a multiplication problem and we flip one of the fractions. The toughest part of this is just trying to remember which one of these two things are you supposed to flip. Do you flip the first one or do you flip the second one? So here, let's examine that in just a little bit more detail. So back in 6th grade, your teacher probably gave you some kind of a mnemonic to help you remember which one was supposed to be flipped over, and it was probably KFC. Keep, change, flip. And the way that it works is that you keep your first fraction exactly the same, you change your division sign into multiplication, and then you flip the second one. Keep, change, and then flip. So have you ever wondered, why do you do that? I'm going to tell you right off the bat that this is just a shortcut. There's no such thing as really keep, change, flip. So instead, let me kind of back this up just a little bit to help you try to understand why keep, change, flip is just like so useful as a shortcut to dividing two fractions. So the way it usually goes is in middle school and especially in elementary school, you're given a process and you're shown how to do that process, adding, subtracting, multiplying, starting to solve equations, but you don't really focus on the why. When we get into high school mathematics, especially in high school geometry, we really start to think about those kind of things. And it kind of mimics the history of mathematics, which goes a little bit like this. This is super brief. People start accumulating math knowledge, discovering math, and then later on, once there's a big enough pool of mathematics to work from, then people start questioning, like, I wonder why all this stuff works. And they start relating things together to try to show why those things actually do the things that they're going to do. So let's do that kind of thing with dividing fractions. Now, I got a question to start off, and that is, what number can you multiply x by, any number, and not change its value? Well, the hint here is right there on this birthday cake. It's the number 1. And we're going to multiply by what I call a fancy 1. And we saw this in a previous video. For example, what is the number 5 divided by 5? It's 1. What's pi divided by pi? It's also 1. It's just a little fancier than 1 tends to look, okay? So here is the fraction that we're going to start dividing. I've got basically 2/3 that I'm going to divide by 5/7. So I'm going to rewrite this one, not as a multiplication, because remember, we're trying to justify why we're actually turning this into a multiplication problem. So think about this first of all. If you have this problem, this classic problem, 2 divided by 3, you can rewrite that as a fraction as 2/3, right? Does that make sense? The division sign, this is the same thing as a division sign, and this one goes down there on the bottom. Okay, so I'm going to do the exact same thing with 2/3 and divide it by 5/7. So 2/3 is going to be on the top of the fraction, divided by, and then 5/7 on the bottom of the fraction. Okay, do I have an extra page? I sure do. So I'm going to write this problem down, and let's see how it is that we're supposed to divide this thing that I'm going to call a complex fraction. Complex fraction happens when you have a fraction inside of another fraction. So you got two of these fractions inside of one big fraction. They're called complex fractions. Algebra 2, you need to take this to the next level. Instead of just having numbers here, you can have like variable expressions and stuff like that too. Should be fun. Okay, so we have 2/3 divided by, I think it was 5/7, right? 5/7. And what I'm saying is that we're going to rewrite this as the fraction 2/3 divided by the fraction 5/7. Okay, so I'm going to multiply this by a fancy one to try to resolve this complex fraction. And the fancy one that I'm going to do at first is the number 3 divided by 3. Again, this thing I'm calling a fancy one because 3 divided by 3 is the number 1. And watch the magical thing that's about to happen. It's not really magic, it's just math. So when I take this 2/3 and I multiply it by 3, what's going to happen is that these 3's are going to cancel. I'm going to do this kind of right off to the side over here. I'm going to take 2/3. When you multiply that by a whole number, 3, I'm going to rewrite that as 3/1. And then I can cancel out these two 3's because I have one on the top and one on the bottom. Again, this is what we saw in the previous video, is that you can rearrange these factors as a 3/3 times a 2/1, and then this is our fancy one we would just cancel out, right? And the same thing is going to happen here, that this 3 is going to cancel out with this 3, and across the top it's just going to leave me with the number 2. On the bottom, I'm going to do the same thing. I'm going to multiply 5/7 multiplied times 3. When you multiply a fraction times a whole number, it just gets multiplied times the top, not the top and the bottom. So again, it's sort of like putting this as a 3/1, and then it's top times top and bottom times bottom. That's going to give me 15/7. This is still a complex fraction. I have a fraction inside of another big fraction, so I got to fix it. So the way that I'm going to fix it is that I am going to multiply by another fancy one. What do you think it's going to be this time? So since I need, what I multiplied before was 3/3. It was to get rid of the 3 up here. I'm going to multiply this one now by 7/7, which is going to get rid of the 7 that's on the bottom. This is pretty complicated, right? Like there's no way back in the 6th grade your brain would have like been able to follow this. It's a little bit more mature now, and I think that maybe you can handle it with a little bit of guidance here. So, okay, now let's fix this multiplication problem now. And notice that like I've actually not done any division. I've just been multiplying here. Whenever I simplify this fraction, top times top here, I get a 14. And then just like when I cancel this 3 with this 3, same thing is going to happen with these 7's. They're going to cancel out, and then I'm going to get 15 on the bottom. Whoa, imagine having to do that every single time that you had to divide fractions, right? Nobody would want to do it. I think nobody wants to do it anyway, but still, nobody would want to do it even more. Now, let's go back to the original problem here. When I have 2/3 divided by 5/7, and doing the keep, change, flip shortcut, this would turn into 2/3 times, no, I didn't change it. I mean, flip it. It should be 7/5. And now when I multiply straight across, 2 times 7 gives me 14. And 3 times 5 gives me 15, which is pretty much the same thing that I got before, right? But which one would you rather do? I think that's a pretty easy question to answer, right? Now, here's something that's super strange, and this might blow your mind, especially if you haven't turned the video off by now. And it goes like this. Don't you think it's strange that there is a different rule for division that there is for multiplication, let's say? Because there's not a different rule for adding and subtracting fractions, it's exactly the same. So why the heck is there a different rule for dividing by fractions? And the answer to that question is that there's not. There absolutely is not. And I'm going to show this to you too. So let's say that I have the exact same problem, 2/3 divided by 5/7. I'm going to tell you that it's the same exact rule as multiplying. Multiplying, if this was a multiplication problem like this one here, it's top times top and bottom times bottom. Watch this. This is going to be top divided by top, bottom divided by bottom. I'm going to rewrite this as 2 divided by 5 over 3 divided by 7. And that might really, really upset you a little bit, like, I guess, intellectually, because you're like, there's no way that's going to work. I've never been taught that. I've never been shown that, but watch what is about to happen. And I think this is really going to cement the whole keep, change, flip thing down. Watch. All right, so I'm going to rewrite this like I did before, as in 2 divided by 5. I'm going to make that into a fraction 2/5. 2/5 divided by, and then on the bottom here, this is going to be 3 divided by 7. So 3/7 here, 3/7. And you know what I'll go ahead and do here is I'll just go ahead and multiply by a fancy one to get rid of this complex fraction. And the fraction that I'm going to choose, the fancy one that I'm going to choose this time, is going to be 35 over 35. The reason why is I'm going to get rid of both of these fractions at the same time. The common denominator between the 5 and the 7 is 35, and so that's the reason why I chose it. I could have done that back up here, but I selected to do one denominator at a time, so I could have made it just a little bit shorter if I found a common denominator to get rid of these complex fractions here. So now watch what's going to happen. I am going to cancel out some common factors. 5 divides into this 35 exactly 7 times, right? It's 5 times 7, so the 5's cancel out. I can think of it really like this, 5 times 7, and then these 5's cancel out. And then likewise, the 7 is going to divide into this 35 and leave you with 5 left over, because again, it's 7 times 5, and the 7's will cancel. Here, just for clarity, I'm just going to go ahead and rewrite this problem. So the only thing that I'm left with up here is the 2, and the only thing that I'm left with over here is the 7. So it is 2 and then times the 7. And then on the bottoms of each of these things, the only thing that's left over is 3, and this one has a 5. So a 3 and then a 5. Here. Let me bring this original problem down and just show you what just happened. 2/3 divided by 5 over 7 is the same thing as 2/3 times 7/5, which is keep and then change and then flip. So why do all of this work right here, especially when it's highly complicated, very easy for you to make some sort of mistake, when you can just take a shortcut, in this case, the keep, change, flip. I'm multiplying by the reciprocal in order to do a division problem. So going back to our actual problem that we have to do without giving you the answer, just think about this one. I got to keep, I got to change, I got to flip, and then I'm multiplying.